In today's review, we are going to go over the Unit 6 pre-assessment. I encourage you to pause this video often, stop and take screenshots, pause, and see if you can deepen your understanding as we look at it, because I'm going to go through it very quickly. So, let's start with number 1. The first thing I want to do when I take any test is I want to read the directions in full. So I'm always going to make sure that I read the directions in full. Number 1, here are some statements about rhombuses. Write true or false beside each statement to show whether it is true or false. Then use the properties of shapes to explain each answer. I know in this question that I'm going to be writing true or false, and then I'm going to use properties of shapes to explain answers. I've underlined the important information to show me what I need to make sure that I answer, okay? So they give me an example. A rhombus is a trapezoid. Is that true or is that false? Well, it is false. Now there may be different explanations, but one way you could explain this would be to say a trapezoid has exactly one pair of parallel sides and a rhombus has two pair of parallel sides, so it can't be a trapezoid, okay? You'll be wanting to think back to that quadrilateral hierarchy that we drew before. Let's look at A. A rhombus is a parallelogram. So that you're going to think, okay, well, I know what my rhombus likes, and I know that a parallelogram has two pairs of parallel sides, and a rhombus does. So, true. A rhombus has two pairs of parallel sides, which makes it a parallelogram. A rhombus is a rectangle. Now I think to myself, well, I know that a rectangle is like this, and it has right angles, but a rhombus is like what I drew over here, so that has to be false. A rhombus does not have to have 90-degree corners, but a rectangle does, okay? You want to make sure that you are writing in clear sentences and using properties of shapes or mathematical language. C. A rhombus is a quadrilateral. This, I might think to myself, well, a rhombus has four sides, which all quadrilaterals have four sides, so that is true. A rhombus has four sides, which make it a quadrilateral, okay? D, a square is a special kind of rhombus. Now I think to myself, a rhombus has two sets of parallel sides and four congruent sides, and so does a square, but it also has 90-degree angles at its corners. So, indeed, a square is a rhombus with 90-degree corners. All right, if you're unsure about any of these, go back and review the quadrilateral hierarchy. You will need to know all about quadrilaterals tomorrow for your test, okay? So make sure that you know your quadrilaterals. Number 2, why do people say that a square is a special kind of rectangle? Use properties of shapes in your answer. Now I know that I can't just say because it's the same shape. No, it's not. They're different shapes. I know that I need to use properties of shapes. So your answers here could vary, but things that you might want to mention are that rectangles are parallelograms that have 90-degree corners. A square is a specific rectangle that has four congruent sides. So you're thinking about the relationship. My rectangle here has two sizes of sides, whereas my square has four different sides, so maybe I described it in that manner. Again, review your quadrilateral hierarchies, know how to explain and differentiate all of these different quadrilaterals. Moving on to page 2. Use this coordinate grid to complete the following problems. To use a coordinate grid, I need to remember that coordinate grids are graphed by x and y along the x-axis and vertically the y-axis. Those are the things that I would be thinking ahead when I see coordinate grid. Now, it says, write an ordered pair for each point shown on the grid. Now, the points shown on the grid were here and here. So, they looked over on the x-axis first, and then up on the y-axis second. So, first we see 8, 1, and then we see here 6, 4. Add the ordered pairs to the grid and label each one. 8, 8, and 10, 4. You see that they didn't skip any part of their directions. They add the ordered pairs and then labeled them. So you see 8, 8 here over on the x, up on the y, and 10, 4 over on the 10, the x, and up on the y, the 4. And then each are labeled with their ordered pair in the proper order. Part C. Connect the points of the grid to form a quadrilateral. Circle all the names that could be used to describe the figure you made. Connect the points means to draw lines in between them. You see that they've done this, and now we've created a quadrilateral. This quadrilateral can be called a polygon. A polygon is any shape with 3 sides or more that is closed. So all quadrilaterals are polygons. And this one is a kite. We see that there are no sets of parallel sides, and that means we definitely can't have a rhombus. But you see that these 2 sides are equal and these 2 sides are congruent as well, making it a kite. Okay? Now, number 4. If you have a question like this on your test, you will be given the measurements, so that's a little bit different. Whatever you chose here to represent is absolutely fine as long as you wrote your equation down. Maybe you chose 6 times 1 times 2. Maybe you chose 2 times 3 times 4. Whatever it is that you wrote down, that's okay. If you had had this on a regular piece of paper and you had measured it, then you would have gotten 2 centimeters, 3 centimeters, and 4 centimeters, meaning that you would use the equation for volume and you would have multiplied length times width times height, which would have given you 24 centimeters cubed. Now this part is really important. You must always label. And if you're measuring for volume, it's always going to be centimeters cubed or inches cubed, anything cubed being that 3, okay, because 3 measurements, so you call it a cube. Now, part B says circle the formulas, that's important, you could use to find volume of the prism. There are 2 formulas you can use to find volume, that one that we always use, length times width times height, or base times height. Base being the area at the bottom, which is equal to volume, or is equal to area, excuse me, and that's length times width, okay? That's your base, all right? So you can have base times height, or you can have length times width times height. 2 options. All right, going on to page 3. The area of a rectangular prism is 45 centimeters. I'm going to underline that. The height of the prism is 6 centimeters. Sounds important. What is the volume of the prism? Okay, the volume of the prism. Use numbers, labeled sketches, or words to model and solve. Now, I might have known that volume equals base times height. So if I think about this, I'm going to have volume equals 45 times 6, and then when I solve, I find 270, and I don't forget to label centimeters cubed. You might have thought about drawing a picture, and if you did, that's absolutely fine. I love to map things out, and you might think to yourself, this is 45, and this is 6, okay, because 45 is your base. All right. Number 6. If Matthew knows the volume of a rectangular prism is 132 meters cubed and the area of the base is 22 meters cubed, what is the height? Again, I'm thinking volume equals base times height. Can I find this out? I absolutely can, because I know that volume is 132 and that base is 22. And then all I have to do is figure out what times 22 equals 132. And I find that it is 6 meters. Great. Let's take a look at number 7. Katie measured a mini candy bar in the shape of a rectangular prism. It was 5 millimeters tall, 40 milliliters long, and 20 millimeters wide. So here I have a lovely little drawing. I might right away think, okay, 5 millimeters tall, 20 millimeters wide, 40 millimeters long. Then she stacked 2 of the mini candy bars on top of each other. What is the volume of the 2 stacked candy bars? So I could do this in a couple of different ways. I might want to do it like is shown here. That's probably the easiest, is just find the volume of one of the candy bars and then multiply by 2. So I do 5 times 40 times 20, and then I multiply that and I find that it is 4,000, and I multiply the whole thing by 2 and I get 8,000 millimeters cubed. Again, that millimeters cubed is really important. Do not forget to label your work. Last page. Number 8, Darius used tiles to build the sequence of growing squares shown here. Okay. Record the perimeter and area of each of the squares in the table below. The first one is done for you. So now I'm thinking, okay, what is perimeter? Perimeter is my distance around the outside, okay? It's the distance around the outside, so it would be the length plus the width plus the length plus the width. And then I'm thinking area. Area is length times width, okay? Perimeter and area. The first one is done for you. So I look at square 1 and I think, okay, Well, square 1 says the perimeter is 4, so this must be 1, 2, 3, 4. And then the area is 1 because there's 1 cube inside. So then I'm looking to square 2, and I think, well, if this is 1, then there's 2, 3, 4, 5, 6, 7, 8. That's my perimeter. Then inside I see 4. That's my area, okay? So I would continue to do this, and you would see that square 3 is a perimeter of 12 and an area of 9. Square 4 is a perimeter of 16, an area of 16. And square 5 is a perimeter of 20 and an area of 25. Now, Darius decided to make a graph about his sequence of squares, but he was only able to partly finish. Did Darius graph the area or the perimeter of the squares? You would see Darius's points in black, okay? And if you look at Darius's points, you see that, well, he graphed 1, 1, and then he graphed 2, 4. So as you're looking at this, you're seeing he's graphing the area pattern, okay? So you would have written down the area. Then number 2 says label each of the ordered pairs that Darius graphed. So labeling 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, 7, 49. And you can label those by continuing the pattern out yourself or by actually doing the counting on your x-axis and your y-axis. Then part C, making sure I don't skip any step, okay? Graph and label the ordered pairs for the other measurement and fill in the key. So down here you'll see your key. Those red dots were measured for his area. Then you are doing the perimeter dots. So you would have filled in a dot at 1, 4, right? And then you would have had one at 2, 8. And then one at 3, 12. Where am I getting the 1, 2, and 3 from? Square 1, square 2, square 3. Okay, 4, 16, and 5, 20. And then you could have continued the pattern on and on to get to 624 and 728. Okay, increasing by 4 each time. Now that you're finished with that, part D, describe the shape of each set of points on the graph, the points for the perimeters of the squares and the points for the areas of the squares. Why are they different? Now this is really important. When you describe this, you need to be really clear. You need to make sure you use mathematical language. So something like, the points for the perimeters go up in a straight line. The points for area go up in a curve. And as they go on, they get bigger than the perimeter. That's different because the perimeter only adds 4 more each time, as you saw in this pattern. The area goes up by more and more each time. It gets exponentially larger and larger and larger. So you can see, you can track those lines. Perimeter increasing by 4 each time, whereas the area is making a little curved line going upwards, okay? So you're talking about the line shape, and you're talking about the amount that your ordered pairs increase by every time to make sure that you have that mathematical language. If you have any questions, make sure to ask your teachers. Take your time to review this as much as you need. Your post-assessment will be very similar because we're covering the same topics, so good luck, and I hope you feel prepared.